Hello science fans, are you ready to embark on a journey across our solar system? Today we're talking about asteroids, giant space rocks left over from the birth of our solar system. These mysterious objects have been drifting through space for billions of years, acting as time capsules from the earliest days of our cosmic neighborhood. These ancient objects are like cosmic fossils, preserving the history of our planetary neighborhood. By studying them, we can unlock secrets about how planets, including Earth, were formed, and what ingredients were present at the dawn of our solar system. Most asteroids orbit between Mars and Jupiter in the asteroid belt, but it's not as crowded as movies suggest. You could fly through and not see a single one. The belt is vast, and the asteroids are spread out over millions of kilometers, making collisions surprisingly rare. There are millions of asteroids, from tiny pebbles to Ceres, a dwarf planet hundreds of kilometers wide. Some are so small you could hold them in your hand, while others are massive enough to be considered miniature worlds in their own right. Some are rocky, some metallic, and some even contain water ice. Their diverse compositions tell us about the different environments that existed in the early solar system, and some may even hold the building blocks of life. Jupiter's gravity can fling asteroids out of the belt, sending them toward the inner solar system. This powerful planet acts like a cosmic slingshot, sometimes protecting Earth, but occasionally sending asteroids our way. These are called near-Earth asteroids, or NEAs, and scientists track them closely. By monitoring their paths, we can predict potential impacts and learn more about the dynamic nature of our solar system. Asteroids are more than just space debris. They hold clues to our past and sometimes pose a rare threat to our future. Their impacts have shaped the history of Earth, and understanding them helps us prepare for what might come. Understanding them is crucial for planetary safety. Scientists around the world are working together to develop ways to detect, track, and even deflect hazardous asteroids. They're a fundamental part of our cosmic environment, orbiting the sun alongside planets, comets, and other celestial bodies. So, next time you look up, remember, our solar system is full of these ancient travelers. They may be invisible to the naked eye, but they're always out there, silently circling the sun. They connect the story of our planet to the wider universe, linking us to events that happened long before humans ever existed. Studying asteroids isn't just cool science, it's essential. Every rock we study brings us closer to understanding our place in the cosmos. Let's dive deeper into why they matter and discover the incredible stories these space rocks have to tell. You might wonder, how dangerous can a space rock be? At tens of thousands of kilometers per hour, even a 1-kilometer asteroid packs more punch than all the world's nuclear weapons combined. The impact would vaporize itself and much of the Earth's crust, creating a crater over 15 kilometers wide. Shockwaves would flatten everything for hundreds of kilometers, and wildfires would rage across entire regions. If it hit the ocean, a mega tsunami would sweep over coastlines, destroying cities and ecosystems. Dust and vaporized rock would block sunlight, plunging Earth into darkness. This is what happened 66 million years ago, wiping out the dinosaurs and most life on Earth. The food chain collapsed, and 75% of species vanished. One big rock can truly change the world forever. It's all about the energy released on impact. That's why scientists take asteroid threats seriously. Even a single impact can reshape our planet's history. Imagine, for a moment, a scenario so extreme it defies belief. Every known asteroid, all the millions in the asteroid belt, the distant Trojans, and the unpredictable near-Earth asteroids suddenly hurtling toward Earth, converging on our planet at once. The sky would ignite into a relentless, fiery storm, with thousands of blazing projectiles streaking through the atmosphere every second. Night would turn to day as the heavens rained fire, and the world below would be illuminated by the chaos above. The combined mass of these asteroids is about 4% of our moon, but the energy unleashed by millions of simultaneous impacts would be beyond anything humanity has ever witnessed or even imagined. This wouldn't be a series of isolated explosions, it would be a continuous planet-wide cataclysm, with the surface of Earth erupting in a never-ending barrage of impacts. Every region, land, sea, the frozen poles, and the equator would be struck at the same instant. No place would be spared, and nowhere would be safe from the onslaught. The The energy released would utterly dwarf the asteroid that wiped out the dinosaurs, fundamentally altering Earth's geology and atmosphere in mere minutes. The shock waves would circle the globe, and the heat would vaporize everything in its path. The ground itself would melt and flow like liquid. As the planet's very structure is battered and threatened by the relentless impacts, it would be less like a series of asteroid strikes and more like Earth being tossed into a cosmic blender, torn apart and mixed by unimaginable forces. The impacts would punch deep into the crust and mantle, exposing the planet's inner layers and sending shockwaves through its core. In the aftermath, survival wouldn't just be impossible for life, it would be uncertain for the planet itself. Earth might never look the same again. This would be a true planetary reset, an apocalypse on a scale that stretches the limits of our imagination, leaving a world shrouded in dust, fire, and silence. Thankfully, this scenario is pure science fiction, a cosmic nightmare that will never come to pass. But it's a powerful reminder of the raw, untamed energy locked within these ancient rocks, silent travelers from the dawn of our solar system, holding the power to reshape worlds. In the first moments of this impossible event, millions of asteroids would ignite the sky, creating a canopy of fire brighter than 1,000 suns. The night would vanish in an instant, replaced by a blinding, relentless storm of light and heat. Every horizon would be ablaze, as if the very fabric of the sky was tearing apart. Surface temperatures would soar to unimaginable levels, flash-boiling oceans and lakes, vaporizing rivers, and incinerating all life before the first impact even landed. Forests would erupt into flames, and deserts would become even more inhospitable, scorched by the relentless heat. Then, the impacts themselves would turn the entire surface into a continuous explosion, shattering the crust, and sending seismic waves through the planet. The ground would buckle and split, as if the Earth itself was being torn apart from within. Mountains would crumble, continents would fracture, and the atmosphere would be blasted into a toxic, superheated plasma. The air would become unbreathable, filled with ash, smoke and deadly gases, blocking out the sun for any survivors. Winds at supersonic speeds would scour the surface, ripping apart everything in their path, and the sky would glow red with vaporized rock. Storms of fire and ash would sweep across the land, leaving nothing untouched. The entire surface would be resurfaced in minutes, melted, pulverized and churned. Rivers of molten rock would flow where cities once stood, erasing every trace of civilization. The energy released would equal billions of nuclear bombs detonating everywhere at once, a force beyond anything humanity has ever witnessed or imagined. There would be no ground zero. The whole planet would be ground zero. From pole to pole, every continent and ocean would be caught in the chaos with nowhere left untouched. Earth's surface would be erased, replaced by a molten sea of rock and fire. The world as we know it would be gone, replaced by a hellish landscape of liquid stone. It's the most violent planetary makeover imaginable, a transformation so complete, nothing of the old world would remain. What about the oceans? They'd face instant violent destruction as millions of asteroids slammed into the water. The impacts would flash-boil vast quantities of ocean, sending colossal plumes of steam into the atmosphere. The surface would boil away, and a thick shroud of steam and toxic gases would envelop the planet. Mega tsunamis would become a global phenomenon, but the ocean would churn more like a boiling cauldron than waves. Land and sea would blur into a superheated slurry of water, mud, and magma. Much of Earth's water could be lost to space or transformed into a toxic, acidic soup. The blue planet would lose its defining feature. The oceans, cradle of life, would become a boiling, lifeless cauldron. After the firestorm, Earth would be shrouded in a thick, impenetrable blanket of dust and vaporized rock. Sunlight would vanish, plunging the planet into darkness for years or even centuries. Temperatures would plummet, and toxic acidic snow would cover the shattered landscape. Earth would enter a deep, artificial ice age, far worse than any natural one. The atmosphere would become thick, toxic, and unbreathable, with crushing pressure. Acid rain and snow would erode what's left of the land. Weather would be replaced by a slow, toxic settling of dust. Life would be impossible on the surface. Earth would become a frozen, silent, and hostile world, waiting centuries for sunlight to return. Could anything survive this catastrophe? The answer is no. The initial heat would vaporize all surface life instantly: humans, animals, plants, even fish. Underground bunkers and deep-sea life wouldn't last. Seismic shockwaves and boiling oceans would destroy even the hardiest organisms. This wouldn't just be a mass extinction, it would be total planetary sterilization. Billions of years of evolution erased in hours. The entire tree of life would be cut down to the root. Only the most resilient microbes, buried miles deep, might survive. If any did, it would take millions of years for life to return. Earth would be a dead planet, starting over from scratch. The ultimate extinction event. Back to reality. Today, scientists are vigilant about asteroid threats. This field, called planetary defense, is like a global neighborhood watch. Telescopes on Earth and in space scan the skies nightly for near-Earth asteroids. Programs like Pan-STARRS and the Catalina Sky Survey report new finds to the Minor Planet Center. Scientists calculate orbits, project future paths, and assess impact risks. Over 90% of the largest, most dangerous asteroids have been found, and none threaten us for now. The challenge is finding smaller, yet still dangerous asteroids. The search continues because early warning is our best defense. When it comes to asteroids, knowledge is safety. If we find an asteroid on a collision course, we don't just wait, we act. Scientists are developing ways to deflect dangerous asteroids, not destroy them. The kinetic impactor method, crashing a spacecraft into an asteroid, was proven by NASA's DART mission in 2022. Another idea is the gravity tractor. A spacecraft gently tugs the asteroid onto a safer path, using its own gravity. Futuristic concepts include lasers to vaporize asteroid surfaces, nudging them off course. The key is early detection. Tiny changes, made years in advance, can save the planet. International cooperation ensures a global response if a threat is found. Unlike the dinosaurs, we have the tools and teamwork to protect ourselves. Dedicated people are watching the skies. For the first time, we're not helpless spectators. We are guardians of our own planet.